In this review, we're going to look at special angles as they appear in special triangles and the unit circle. We'll start with special triangles. There are two special triangles that you must remember, and they are the 30, 60, 90 triangle. As you can see here, 60 degrees in this angle, 30 degrees here, and 90 degrees. And the measurements are 1, root 3, and 2. An easy way to remember where the root 3 occurs, the root 3 occurs right by the 30 degrees. It's always adjacent to the 30 degrees, and then 1 and 2. There's also the 45, 45, 90 degree triangle. And this one's a little easier to remember because it is an isosceles triangle, which is that these two sides right here are both 1, and the hypotenuse is root 2, and the angles are both the same, 45 and 45. You can use these triangles to find the exact trigonometric ratios of special angles for 30 degrees, 45 degrees, 60 degrees. So we're going to take a second and fill this one in. So first what we're going to do is we're going to find the sine theta for 30 degrees, or if you had theta in radians, that would be pi over 6 radians. So sine of 30 degrees, if we do sine, that is opposite over hypotenuse. So sine of 30 degrees is 1 over 2. Now, if we were to do cos, cos is adjacent over hypotenuse. So that would be root 3 over 2. Okay. And then if we were to do the tangent ratio of 30 degrees, the tangent ratio is defined as opposite over adjacent. So that would be 1 over root 3, or if you were to rationalize the denominator, that would be root 3 over 3. Doing the same thing for the 45 degree angle, we would use the 45, 45, 90 triangle. So sine theta right there, and we could pick any one of these angles, it doesn't matter, it's going to result in the same ratio, is 1 over root 2. So sine theta there would be 1 over root 2, or with a rationalized denominator, root 2 over 2. It is the exact same thing for cos, because cos would be adjacent over hypotenuse, right? And so that is also 1 over root 2, or root 2 over 2. And tangent is actually the simplest of the two, because, or the simplest of the three rather, because it's opposite over adjacent, so it's just 1 over 1, or simply 1. Okay. We can take a second and fill in 60 degrees all on our own. The following are the answers for the sine, cos, and tan for 60 degrees. Moving on, we can talk about the unit circle. Now, the unit circle can be used to find the cos, sine, and tangent of any angle. However, the unit circle is most helpful in helping us define what the sine, cos, and tangent ratios are for angles like 90 degrees, 180 degrees, 270 degrees, 360 degrees, or 0 degrees, because those are coterminal. So in the unit circle is basically a circle on the Cartesian plane with the center at the origin. The unit arm, or rather the terminal arm, has a value of 1. So r is always equal to 1. That's the length of the terminal arm. And it's called the unit circle because it has a radius of 1. And so therefore, with a radius of 1, r is always equal to 1. That makes cos, sine, and tan very easy to find because cos is x over r, but if r is 1, that's x over 1, so cos is equal to just x. Same thing with sine. Sine is y over r, but if r is 1, then sine theta is just equal to y on the unit circle. And then for tangent, that's y over x, which is actually the slope of the terminal arm. So we can use the unit circle to determine the exact values for certain angles. So if we were to find sine of pi over 2, well, that's the same thing as saying sine of 90 degrees. Well, if we're right at 90 degrees, that means that this angle here is 90 degrees. So that puts the terminal arm straight up right there. As we know, r is always equal to 1. At this point right here, we have the coordinates 0, 1. So the x value there is 0, that makes sense, and the y value there is 1. So the sine of pi over 2, or sine of 90 degrees, is actually equal to just y over r, again, y being 1, r being 1, because the radius of the unit circle is always 1. So sine pi over 2 is equal to 1, and we can write that. So sine 90 degrees is equal to 1. All right? Now, if we were to just quickly think about this, what would the cos of 90 degrees be? Well, the cos of 90 degrees would be defined as x over r, and x in this case is 0, 0 over 1, so cos of 90 degrees is equal to 0. Finally, if we wanted just to quickly take a look at what tan of 90 degrees is, tan is y over x. Y would be equal to 1, x is equal to 0, and therefore it is undefined.